Good afternoon. My name is Chris Magruder. I'm the AUT manager for ONDT, and I'm here this afternoon to explain to you a new system called our WeldROVER. The WeldROVER is part of our PV200 series of products that includes the mechanical scanner, our new Weld series probes, OmniScan or Focus LT instrumentation, and the integration of the system with our latest software. With nearly 3,000 OmniScans in use today and growing rapidly every day, the number of customers requiring and requesting full mechanized AUT brought this system to the market. Previously, to offer full mechanized phased array and topped inspections, it required motion controllers, programmable software, complicated bidirectional scanners, and a long, complicated training track. With the introduction of the WeldROVER system, that technology is now available in an economical package that can be transferred with a reasonable amount of training in a reasonable amount of time. Applications brought to ONDT from our existing customers or from potential new customers can generally be put into one of two categories, and that is in-service inspection and new construction. The overwhelming majority of these systems entering the market are sold for new construction purposes, and that means compliance with existing codes and rules such as ASME, API, AWS, DNV, and the various codes and regulations used throughout the world. To comply with those codes, we generally have to treat every single A-scan with respect to calibration and linearity the same as we would a single channel conventional UT instrument under the same codes and procedures. ONDT equipment is unique in that regard. With respect to the ASME codes, they have been particularly proactive accommodating the phased array technology through the release of several code cases facilitating these inspections. Those code cases include rules and regulations for both manual phased array and automated phased array inspections. And those would include for ASME Section 5 code cases 2541, 2557, and 2558. For the ASME Section 8 pressure vessels, code case 2235. For the ASME power piping B311 and B313, code cases 179 and 181. When we're replacing radiography in new construction environments and we're offering advanced services, it is imperative that the equipment has the capability of complying with those codes verbatim in an easy to use, easy to transfer system such as the WeldROVER. In transport mode, the entire system fits into two 50-pound cases that can be checked into an airline without an overweight, oversized charge. They can also be shipped using standard FedEx and UPS or other ground services. Typically, the accessories kit would stay in the truck, in an office, or in a common area not needed on the actual inspection job site. It includes room and a compartment for optional laptop for computer-based inspections or offline analysis. It has plenty of room for spare probes, the spare parts kit, accessories, cabling, water supplies, other peripheral equipment, and it is responsible for transporting the OmniScan in transport mode. Preparing the scanner for the pipe inspection requires making adjustments both for the diameter using these controls and for the probe position on the index axis in and out, and taking a measurement of the distance between the probes. It requires only one tool and a ruler. So we place the scanner on the pipe, apply pressure to the head unit, making sure no cables are being bent at a sharp radius. Hand tighten the retaining bolts, snug them up with the hex tool provided. And now we're going to move the probes in and out on the index axes in accordance with our scan plan. Snug them down tightly. Take a measurement of the center to center between the probes and take a measurement on the scan axis for the scan offset between the probes that will change with each diameter. Quoted with a standard WeldROVER system would include Weld Series probes and wedges. These are an improvement over previous designs for both manual UT and automated UT by a more efficient, ergonomically designed housing, smaller footprint wedges that come in the various element, pitch count, and size and frequencies, and improved design in the wedges. A standard wedge previously would have had water ports and guide pins integrated into the Rexolite wedge. Those have now been moved to an aluminum housing so those parameters can better be controlled and not a function of the consumable wedge. The small footprint also allows us to scan smaller diameter pipes without having to contour the wedge, which also allows us to use standard flat calibration blocks typical of conventional UT for our code-based calibrations. To calibrate the system, we want to make sure power is off on the scanner and the laser is not active. We're going to remove the probes independently from the scanner, where we'll have enough slack to be able to manipulate the probe on the calibration block. We take our first calibration point, or TCG point, and take a nice, smooth acquisition. Use the auto calibrate feature. Move the gates to the next target. Back the probe up. And take the next acquisition point, or TCG point, and continue as necessary. The probes are calibrated independently, one at a time, and upon completion we save the calibration and install the probes back in the correct position. Both the operating system and setup files and data acquired are stored on commercially available flashcards. These can be purchased up to 16 gigabytes now, compatible with the OmniScan. A typical 12-inch weld would be approximately 50 megabytes, and we could literally store hundreds of them on the flash card, but we would typically download at the end of every inspection period or work shift. The WeldROVER is quoted with 2 water supply options for the couplet. The first and probably most common option is using a simple manual pump typical of a bug sprayer. It provides even pressure operated by the handle close to the operator for water supply through all of the probes. The second option for the couplet supply is an electrical pump that requires a 110 or 240 volts outlet power supply or from a generator. It provides a higher flow adjustable couplet and is typically used in fixed stations or where the system is set up in a truck or doesn't need to be as mobile as the bug sprayer type option. Align the laser directly over the weld and gently place the footprints of the probe in the correct position. And as you lower the scanner, the magnetic wheels will grab the pipe in line. The remote controller for the scanner is a very simple 3-button device. It can be set from 5 millimeters to 50 millimeters per second, constant speed, irregardless of the weight of the scanner or where the scanner is positioned along the weld. We can jog the scanner in 2 directions. It's encoded in both directions, or we can hold the button down 1 time for constant motion control. We can change speeds during the acquisition to maximize our scan time as long as we don't exceed the acquisition rate of the instrument. In addition to the remote control, we also have an emergency stop built directly onto the scanner for CE compliance and completely disables power to the scanner. The umbilical that comes standard with the WeldROVER is made of flexible conduit. It can be reconfigured, it can be opened up, it comes in varying lengths depending on the application, and it consists of the phased array probes, a splitter for the 2 probes, an adapter that allows us to use conventional probes, Toft, Pulse Echo, OD, and ID creeping wave probes with the phased array, the power supply for the scanner, and the water supply for the couplet. The Toft option allows us to use 2 dedicated Toft channels through a remote pulsar receiver to boost the signal as a result of the phased array using only 45 or 90 volts selectable. Built into the scanner, but removable, is a remote pulsar receiver that allows us to boost the conventional probes up to 200 volts. It allows 2 dedicated Toft channels of 4 probes or conventional UT channels. And the flexible umbilical can be adapted appropriately for the various coaxial cables required. In addition to acquisitions and analysis using the OmniScan user interface, we also have space available both for acquisition and offline analysis for a ruggedized laptop compatible with either the OmniScan or a Focus LT for computer-based acquisitions. Align the laser on the center line of the weld, gently place the footprint of the probes in place. Verify that the laser is aligned with the weld. Preparing the OmniScan for start acquisition, enable the water supply, ensure your cabling and remote aren't obstructing the scanner, visually verify the laser is tracking on the weld, apply a pressure on the guide bar if necessary. Extreme caution should be used to ensure that the cabling and umbilical is not snagged by the scanner or obstructed. Follow the scanner completely around to the 0 reference point from the start of the inspection. Stop the scanner. Pause the OmniScan for the data. The guide bar can be inserted on either side of the scanner, and it's used both for guiding the laser alignment on the weld and for providing tension to remove the 4 magnetic wheels off of the pipe. It's inserted and screwed into place. Place 1 hand on the scanner and 1 hand on the guide bar to break the front magnetic wheels first, and then continue applying pressure against the back of the scanner and gently remove the scanner off of the pipe.